Hello viewers! Today in this video we will be discussing Lynn Creek, also known as Lynn Canyon, as well as Lynn Headwaters. Specifically, we will be discussing the main processes causing change to the physical landscape of the field site, as well as the processes that have already caused change to the field site. Here you can see that Lynn Canyon is very steep. We will be discussing how this canyon was formed further in the video. Lynn Creek is a drainage basin. A drainage basin can also be called a watershed, river basin, or catchment. These terms all describe a stream or river that has many smaller streams, which are called tributaries, that feed into it. I have drawn a diagram here to show you an isolated version of Lynn Creek. Keep in mind this is a rough sketch. Outlined in red on this topographic map are some major tributaries that run into Lynn Creek. These include Kilmer Creek, Hastings Creek, Kennedy Creek, and Wickenden Creek. There are many more that I have not named. There are also many small tributaries that run through Lynn Canyon Park, which feed into the major Lynn Creek stream, as are pictured here. Now, follow along with me as we explore Lynn Creek and describe all the geological processes that have worked together to form this site. Let's go! Here we are at a clearing beside the creek, which can be accessed via the Varley Trail. Just upstream from this clearing, you can see a confluence. A confluence is where two streams meet and form one larger stream. There are large boulders at the end of the bar where the confluence meets. These were deposited long ago, either by extreme flooding or glacial flecking during the retreat of the Ice Age. Glacial flecking occurs when water carries down large materials which become stuck due to freezing. When glaciers melt, the large materials stay stuck in place. Here is a diagram from bbc.com that shows glacial flecking in more depth. Here you can see that there is a bar between the two streams, which is lush in trees. The trees indicate that the bar has not been flooded in quite a while, because if it was, the trees would have been swept away into the stream along with many of the smaller materials, like rocks, pebbles, and gravel. There is a difference between the rock material in the bed of the creek and the rock material on the floodplain and/or clearing beside it. The rocks on the riverbed are extremely smooth and rounded. This is because of the constant erosion that they experience due to the rushing stream, which is depicted here in this video. The rocks beside the creek are slightly more jagged because they only experience weathering and erosion on occasions of heavy rain when Lynn Creek's water level rises significantly. Due to Vancouver's extremely rainy climate, Lynn Creek's water levels often rise and fall drastically throughout the seasons. Now let's venture towards 30-foot pool. Here we are standing on a terrace above 30-foot pool, a popular cliff jumping location in Lynn Valley. This terrace was once a floodplain. There is evidence of this in the boulders that litter the terrain, which is largely made up of sedimentary materials such as sand. These boulders could not have ended up here unless the water levels of Lynn Creek were once above this elevation. This terrace was formed as the retreat of Ice Age glaciers 10,000 years ago lowered sea levels. Glacier meltwater streams built broad, sandy surfaces such as this. As the water levels dropped eventually, weathering and erosion ceased on this plain, whilst still occurring in the thinner stream. Erosion formed a bank and river cliff, which left this terrace, with its sediments and boulders, elevated. Here is a diagram from Clegg and Turner that describes this in more detail. This diagram is also linked in the works cited slide at the end of this video. As water levels drop, terraces and hanging valleys are left over. Now we are standing on a rock beside 30-foot pool, Lynn Creek's deepest point. Most areas of Lynn Creek have quite a high velocity. However, 30-foot pool has a slightly lower velocity. This is due to its depth and its wider berth. 30-foot pool likely began as a small fracture as a result of glaciers. Eventually, water began to flow through this fracture, as well as waterfalls, which caused weathering and erosion, forming this very deep pool. 30-foot pool, as well as the rest of Lynn Creek, is mainly made up of granitic rock. The rocks pictured here are likely experiencing a physical weathering process called expansion and contraction. Expansion and contraction occurs when sun heats a rock's surface and expands it. At night, the rock cools down and contracts. Over time, the rock forms cracks and weaknesses and eventually breaks apart. These rocks that are pictured here will eventually break apart due to expansion and contraction physical weathering. Now we have transported to the middle of the suspension bridge above Lynn Canyon. The suspension bridge is located over a large, steep canyon. Canyons like this are often formed in areas with resistant, hard rock, such as granite or basalt. Since Lynn Creek is heavily granitic, this makes sense. It is likely that the glacier that used to be here eroded a U-shaped valley. As the glacier melted, the water then eroded the erosion-resistant granitic rock into a V-shaped canyon. It is also possible that this canyon began as a fracture, just like 30-foot pool, and downwards erosion occurred over time, turning it into a very large canyon. Moving forward, Clegg and Turner explain another hypothesis as to how this canyon formed. Clegg and Turner explain that the sea level used to be 250 meters above what it is now. As sea levels dropped, many sediments were left behind, but in some areas it was strictly, or mainly, bedrock. Canyons formed where the river cuts through bedrock ridges, but the open valleys occurred when softer sedimentary rocks were eroded rather than bedrock. Humus, which is decomposing organic matter, is providing nutrients to the soil, which is allowing the plants such as trees, ferns, and other shrubs to grow in this very lush forest. Nutrients from uphill soil is brought down into the valley of Lynn Creek through rain, which makes it extremely good for plants to grow. This soil is most likely slightly acidic and neutral. We can infer this because there are many plants growing in this landscape. Since Lynn Creek is a meandering stream, the river is constantly creating cut banks and river cliffs as well as point bars at different meanders. Oftentimes, slopes like the ones at Lynn Creek would cause mass wasting. The reason that mass wasting doesn't often occur at Lynn Creek is because of the vegetation there. The roots and abundance of plants add strength and cohesion to the slope. And that's it. Thanks for watching.